The subject of today, the first subject, comes from a person who put a comment, and he says, diversity of species already on the downgrade before the asteroid hit Earth. And another fellow doubled up on that and says, there's an article about the Cretaceous extinction on BR, German TV station. It seems mainstream science is catching up. So I looked it up, see what they're referring to. I guess they were both referring to the same article. Maybe they read the same article. And it came out about a week ago. And this is the article. Let me get it up here. Article, what is it? The 29th of June, 30th of June. Says dinosaur biodiversity declined well before the asteroid impact, influenced by ecological and environmental pressures. Okay, and so they go on and they mention what happened about 10 million years. They looked at the last 10 million years prior to the Cretaceous, the KT extinction, the dividing line, which was anywhere, they don't know exactly, it's 65 million to 66 million years ago, somewhere around there. I want to call your attention to one of the persons on the list there, and that's that third one, Michael J. Benton. Okay, he's kind of like the dean of paleontologists in this realm, in the KT extinction, also Permian and so on. He's been around for a while. And he wrote a paper, a 30-year-old paper. I've discussed him in the past, but he wrote a paper in 1990, okay, which I recommend to anyone who wants to, come into the field and just get an overview. I think it's an excellent paper. And that paper deals with the history of extinction theories, okay? Here's the paper. Scientific Methodologies in Collision, the History of the Study of the Extinction of the Dinosaurs. And it's a good paper because he does a pretty good job of going through and figuring out, what the different theories were throughout time. So, it's like a must-read for anyone who gets into this subject. Anyways, he essentially puts two models or two groups of people. We have the gradualist on one side and the catastrophist on the other. The gradualist is a person who says, these things happen over time, the loss of diversity of species, the decline, the slow decline of in other words, they were losing more species as time went by. And the causes are assigned to competition, declining temperature, and marine regressions. The last two, primarily from a fellow named as Robert Baker. I've talked about him in the past. And Baker wrote a book, which I also recommend, The Dinosaur Heresies. Very good book, primarily because, he does a lot of theory in there. He goes into mechanisms. I don't agree with some of Baker's conclusions, especially, but the book is good anyways. It's a good read. Very thick book, but it's a good read. Why? Because Baker goes in there and, again, goes into mechanism, which is what it should be, for anyone who enters this field. Anyways, Benton contrasts the gradualists against the catastrophists. And who are these people? Well, they believe, as far as the dinosaur extinction, that it all happened through an impact of an asteroid. Okay, and he goes in there and says, dust cloud which blocked out the sun, prevented photosynthesis. Okay, and so I guess all the plants died or something like that. In fact, some people say that, exactly that. And so it's got to do with the atmosphere and also with thermal stress. And I synthesize it at the bottom. You see it there on the left-hand side. I said competition and climate change is essentially what the gradualists propose, and the catastrophists propose catastrophes and environmental changes, sudden changes. Okay, so this is essentially the fight, you could say, between that's been going on for a long time. I would say since the days of Georges Cuvier, 200 years ago, we had these two groups. Some people who say it happened gradually, the extinction of animals. The other guys said, no, it happened suddenly. Okay, and so who is right? Do we have enough facts to determine who is right? Okay, that's one of the things you want to keep in mind today. Anyways, I don't think Mr. Benton wrote anything important after that. He never contributed anything at all other than that paper to paleontology. You say, Bill, how can you say that? What are you saying? This man's been around for so long. He's a paleontologist. He's an expert in his field. And before we can really say that and assign authority, we have to figure out what a paleontologist is. what is paleontology? What is paleontology about? And yeah, we look up a definition, and we find in the National Geographic, the study of the history of life on Earth as based on fossils. Wikipedia says the scientific study of life that existed prior to and sometimes including the start of the Holocene epoch. Includes the study of fossils to classify organisms and study their interactions with each other and their environments. Okay? And you look at dictionary.com, it says, what is a paleontologist? It's a scientist who specializes in the study of life forms that existed in previous geologic periods as represented by their fossils. Is that what a paleontologist is? Is that what paleontology is about? And no, the answer is no. Those definitions are not scientific. And I'll tell you why. Science is not the study of. It's not the study of anything. Science is about explaining. You have to explain something. So you studied, and you know nothing. You understood nothing. Does that make you a scientist? You studied for the test on Friday, and you got every question wrong. You got a 0 on your test. Does that make you a scientist because you studied? People have this notion that came from the 17th century so-called scientific revolution that says that, science is an ongoing process. No, absolutely not. Science has nothing to do with a process. Science has to do with explain something. That's when you have to burn your calories up here, your gray matter. But to say that you studied and then you come up with some nonsensical theory, explanation, Mother Nature laughs at such science, so-called scientists. And so, no, what is paleontology? What is this field about? Well, here it is. Paleontology, the branch of science that rationally explains extinction. Okay, paleontologist is a medical examiner. He's a forensic pathologist, a scientist who determines the cause of death of ancient species. In other words, extinction of plants and animals. Okay, that's what a scientist is, especially a paleontologist, right? Paleontology, you have to explain death. You have to explain how animals in the past died, or plants as well. And if you cannot explain that, what do I care if you studied, you collected stuff? Some people have this idea that paleontologist is a guy that goes out there in the middle of nowhere and starts breaking the rock, pulling bones out, dusting them off, assembling them, giving them a fancy name, and putting them in a museum. No, that's not a paleontologist. As Mr. Ernest Rutherford would say, that's a stamp collector. Paleontologist has to tell you something about the death of animals and plants and animals in the past. Once we're done with that, we're done with paleontology for the rest of humanity, for the rest of our history, for the rest of our existence. And anyone who wants to go in there and look at more bones and classify them, they can do that. That part is very specific, and those are specialists who dedicate time to that. The important thing from paleontology is extinction. Once we got that, people don't want to hear all the little details about measurements and how big the tooth was and all these things that you see in the literature out there. We need an extinction theory, and we don't have any extinction theory on Earth today. Okay, for 200 years we've had this discipline known as paleontology, and not one person today can tell you how the woolly mammoths became extinct, how Neanderthal became extinct, how the T-Rexes became extinct, how the mammal reptiles became extinct. No one has a theory of extinction, a foolproof extinction. And you say, well, there's lots of theories out there, El. I mean, what are you talking about? There's only one thing that an extinction theory has to explain, and that is selectivity. If you have not explained selectivity, you do not have an extinction theory, and if you don't have an extinction theory, you're not a paleontologist. We have no paleontologists on planet Earth today. And part of that has to do because, all these people, they go through the courses at the university, and if they want to graduate, they can't buck the trend. They have to toe the party line. They have to publish whatever the previous generation, who are the peer reviewers, want them to publish. So even if they have a bright idea out of the norm, they can't publish it because they would be considered, outside the norm. No, you can't buck the trend. You have to toe the party line if you went through that channel. See, in my case, I don't have to worry about that because I don't know these people anything. I can give you a theory, and does it mean you're going to believe it? No, that's not the point. The point is that I give you a theory so that you can think about it. so that you can reach your own conclusions. But I'm not going to just repeat what all these people do, which is what the previous generation has already figured out, proved, and all they do is regurgitate from one generation to the next the same thing over and over and over again. We've had the same theories for the last 200 years. Okay, and so here's this theory these people came up with. Okay, see if I can get this up here. Okay, and this is what they say in that paper. The most important part, probably, that I, sifted out. The question why non-avian dinosaurs went extinct 66 million years ago remains unresolved. Already their paper starts out on the wrong foot. They're saying, we don't know. After 200 years, we still have no idea why the dinosaurs died. They're telling you that in the first sentence of the paper. Okay, so let's see. The biodiversity of non-avian dinosaurs would have been declining 10 million years before they were finally extinct. Apparently a gradualist here, right? Not a catastrophist. Okay, but it was the impact of an asteroid that killed them off. I like that. You got to be at peace with both God and the devil. Okay, so you shake hands with both of them, and you say, yeah, Mr. Devil, I shake your hands in case I happen to go to hell, and I'll shake hands with God as well, Okay, the mighty asteroid, which today is testified by the Chicxulub crater in Mexico and a thin layer of iridium all over the world, would have changed the climatic conditions of the Earth so abruptly that the habitats of the non-avian dinosaurs were destroyed. So what are these fellows going to talk about? Well, they're going to talk about an asteroid that caused some climatic catastrophe, some sudden change in the climate, possibly the dust that covered the entire Earth, that blocked out the sun, that prevented photosynthesis or normal photosynthesis. Okay, so this is where this paper is going. The climatic conditions. Okay, it says the non-avian dinosaurs did not have the necessary biodiverse and evolutionary tools to recover as a class from the asteroid impact. You have to give, pay homage to the asteroid theory. Otherwise, you don't get your paper published. That's how simple it is. See, I don't have to worry about that because I don't suck up to all these people. So I can give you a theory, and you got to find it like a needle in the YouTube haystack to find me. But once you get here, at least you're going to listen to something that you can sink your teeth into. And so, okay, so it says they could not recover a combination of global climate cooling. Okay, the diversity of herbivores and an age-dependent extinction had negative impact on dinosaur extinction in the late Cretaceous. These factors impeded their recovery from the final catastrophic event, meaning the asteroid. So they couldn't recover. Otherwise, they would have recovered. This is what they're suggesting. Like many say, if that asteroid hadn't hit the Earth, in fact, someone said that in one of the comments, the asteroid hadn't hit the Earth, the dinosaurs will still be around in New York City. My God. Okay, let's find out. What's wrong with this? Because here they're saying the last 10 million years, there was a decline in species. Some of them, because apparently the hadrosaurs expanded. That's what they're going to argue. Their numbers expanded at the expense of others. Okay, but what's the issue here? The issue here is the little fable that I tell about the last 5 Neanderthals. And yeah, it's a fable because the Neanderthals were animals. And so I think I'm okay by saying it's a fable. So you get the last 5 Neanderthals on Earth. And they're in a cave. And they're around a campfire. There's this big boulder. Rolls down and kills all 5 of them. Okay? So now someone asks, well, Bill, how did the Neanderthals die? And I say they died by rock. They rocked. A boulder fell on them. That's how they became extinct. Now, is that a valid theory? No, it's not a valid theory because you have to explain how we ended up with 5 Neanderthals. That's the extinction theory, not the nonsense that a boulder, just by sheer luck, fell on their heads. And that's more or less what we've got here. These people here in this paper, they say for 10 million years, the dinosaurs were declining. And then came this asteroid out of nowhere, an act of God. God threw the asteroid to the Earth and just wiped them out. The straw that broke the camel's back, so to speak. Well, no, we don't care about the asteroid. Because if the asteroid fell to the Earth, it couldn't have been the cause of the demise of the dinosaurs if the dinosaurs were becoming fewer and fewer and fewer in the last 10 million years. We have a little contradiction. The theory is, how did we end up with few dinosaurs? Not what was the boulder that killed, the last 5 Neanderthals. That's not a theory. And so we have to find out why. The real cause of extinction has to do with why we ended up with fewer and fewer dinosaurs. That's the theory. Okay? And so, yeah, I got a problem with first, this middle position. And second, to cover all the bases. Well, it was climate change, it was competition, it was also the asteroid. We put them all together, and boy, that paper's got to be approved by the peers because everybody's happy. The peer who believes in climate change, he'll like it. The guy who believes in the asteroid theory, he'll like it. Everybody likes it. And what is all this for? Is this for science? Or is it to get your name in lights so that you can make more money, make a career? And see, this is the problem we've got in science in general, paleontology in particular, and that's that, you have to bow down to the previous generation. And so it turns out that the working hypothesis, the foundation, always starts from the previous generation. You can't buck the trend because you don't get published, you don't have a career, you don't have any money. If you want to be up there, you want to get your name in lights, you have to start, first by paying homage to the previous generation. And so we've got a series of this for 200 years now, probably less than that, but certainly after World War II, we've had all these theories where one guy just depends on the other guy, who depends on the other guy, who depends on the other guy. And so we can never get out of that because the system that we've created for science does not allow for new theories, for new proposals. That's the problem. And so you're always going to hear the same thing over and over again. From now on, it's going to be, well, the asteroid was not red, it was blue. It was a little bigger, it was a little smaller, and we measured this little. What is that? That's science. The theory is, what? How did the dinosaurs die? Did they die by comet, or did they die for 10 million years gradually? Which is the theory? And when you put it all in there, it's just, all you're doing is sucking up. That's all you're doing. Okay? So how do we explain extinction? In comparison, in contrast, here at this site, okay, we do it a little more rationally. Okay, and so we start by mentioning the following. This is how Mother Nature does extinction. Okay? And she looks at the vitals, what I call the vitals. Breathing, drinking, eating, sleeping, and aging, and loss of genetic diversity. Those are the things that none of us can avoid. Species cannot avoid. Okay? In other words, you need to breathe. And I think we can take that one for granted, even though paleontologists out there, the ones who believe in supernovas, they say that the air was taken out of the earth momentarily, waited for some of the animals to die, then the air came back. We received this big shot from a supernova. It comes from NASA. NASA loves all these extraterrestrial causes because, they've got a big stake in it. And so they give money to all these researchers to provide extraterrestrial evidence, proof, so that they can continue the cycle. That's what it's all about. There is no chance whatsoever of an extraterrestrial, especially a supernova, having caused any of the extinction. In this case, it was the Ordovician. Okay. But those are the vitals. That's what Mother Nature's going to tackle. She's going to get you through one of these. And we're going to eliminate breathing because we're saying, hey, breathing, I think that's, until someone bottles the air, I think we're all safe there, okay? Sleeping, well, again, I think that's not where the issue is. Aging, yeah, aging and low genetic diversity, those are the causes of a background extinction, Neanderthals. And for us, and for all mass extinctions, drinking and eating. And yeah, one of the reasons that none of these paleontologists today have figured out that we are the last generation of humans on Earth. If because they're blindsided, they have no clue what causes extinction. See, if they would have figured out how extinctions happened in the past, they would realize that we are the last humans on Earth. How long do we have to go? I don't think we have 30 more years to go. I don't think we'll make it to the mid-century. That's my personal take on that. I can't give you a date, but we're about to become extinct as a species. All mammals, in fact, the whole order essentially will disappear this century for sure. There's no way we can survive this century. And why? Well, because Mother Nature is going to attack us through what? Drinking and eating. Two vitals. If you don't eat, you're going to die. If you don't drink, you're going to die. So it's a guaranteed thing if we remove eating from all humans on Earth, if we remove drinking from all humans on Earth will die. Believe me. Don't take my word for it, but believe me. Okay, so how does the theory start? Well, I usually like to say that imagine you're at the starting line of the Cambrian, 542 million years ago, or thereabouts. Obviously, there were animals before then, Precambrian, but let's start at the Cambrian line, just arbitrarily, not important. We can predict retroactively now, okay? We can predict what's going to happen. Retroactively because we've already mapped it out in general terms, in the big picture. We have the big picture. We don't need any more evidence. We've got too much evidence as it is. We already have the evidence we need to determine what caused extinction, okay? And if you're standing on the Cambrian starting line, 540 million years ago, and you look forward, you can predict, retroactively, right? You can predict that periodically plants are going to disappear. When, not if, but when plants, entire orders, disappear, the animals that forged a relationship for millions of years, right? Relationship with those plants will disappear with them. Now, why have the so-called paleontologists figured that out? Well, because the worldly wisdom among them is that, well, an animal just switches from one food to another. So if he can't find this kind of food, especially a herbivore, can't find, I don't know, grasses, he'll switch over to some other food, some other plant. That's the worldly wisdom. And what they're saying is that, you have a rabbit, and this rabbit cannot find lettuce, and so he's going to switch overnight to pine leaves, Christmas trees. Is that true? Is that how it works? Do rabbits switch from lettuce to pine leaves? Can a rabbit digest conifers? And no, the answer is no. The animals don't switch at the last moment when something happens in the environment. They say, oh, I can't find some of this, I'll eat some of that. It doesn't happen that way. Can you eat conifers? Can you eat ferns? The answer is no. We don't eat ferns, we don't eat conifers. We eat angiosperms. Okay? And so now imagine an animal, I don't know, in the Permian. And Permian had really two big extinctions. The first half, they had all these sailbacks, lizard-like looking animals like Edaphosaurus and Dimetrodon. Second half, they had other types of mammal-like reptiles, which were like the gorgons and the Brachiosaurs. First guys looked like lizards. The second guys looked like lions and tigers. They laid eggs. Lion laying eggs. Yeah, that's more or less what it was. So there was an extinction 252 million years ago. So they say that's more or less the date they've got. And it turns out that, one of the plants that covered essentially most of the planet was the Glossopterids. The Glossopterids, there were different species of these, but they covered the land. They were seed ferns. Okay? And when these plants went away, just by sheer coincidence, the land animals also went away. Now, isn't that a coincidence? And then you got the Triassic, you have Dicrodiums, another seed fern, which was the end of the seed ferns, by the way. And that's when the Archosaur era came to an end. Now, that's another coincidence, isn't that? And yes, it turns out that all mass extinctions have a major plant that is slowly, essentially dying towards the last few million years. And I call it the shrinking island theory. The island, the jungles, the forests of whatever, is shrinking. And the animals, the herbivores that depend on those plants, they cannot diversify, they cannot expand, they cannot radiate like it did millions of years earlier, their forefathers. Now it's the opposite direction. Now they've grown big through Koch's law. Koch's law means that animals grow big through this arms race typically over time. So they become big, they become numerous, they have fewer children. Okay? And so what do you have? Well, you have first the density dependent issue, okay, density dependent birth rates. Then you have the expansion of big animals that are growing and expanding on a shrinking island. The jungle of what they eat, right, is shrinking and they're expanding. And so, yeah, at some point there's got to be a crisis. Okay? Now, why did the plants disappear? Why are they shrinking? Is it because of climate change, like all these people say? Is it because an asteroid or volcanoes hit the Earth or sprouted plumes from underneath the ground, I don't know, geysers. They can only think of catastrophes. It never occurred to them that plants have their cycle too. All plant species, all orders must disappear. You say, how do you know that, Bill? Well, we know that because that's the history of life on Earth. And here, let me show you the history of life on Earth in a nutshell. Okay, here it is. Okay, this is the big picture. Okay, what you have is the Carboniferous. You had all these amphibians, and it was the age of maybe non-vasculars and early vasculars. When you get to the Permian and Triassic, you get the age of ferns and seed ferns. The age of synapsid, really of mammal-like reptiles. Then when you get to the Jurassic and Cretaceous, you get the dinosaurs. What did they eat? Well, what do you think they ate? If the land was covered by gymnosperms, conifers. And what do we eat today? Well, what's out there? Well, what's out there is angiosperms. That's what we eat. We don't eat gymnosperms, and we don't eat ferns because there was a type of animal that thrived with ferns, another type of animal that thrived with gymnosperms. And you say, well, how did these disappear? I mean, you know, was it by magic? Was it, again, some kind of climate change, which is the only thing these people can think of? Because it's very popular today, you know, in our world. You say, oh, climate change, we've got to do something about it. So all they can think of is climate change, and they know they're going to get their paper published because they just mentioned the term climate change. And so this is all they can talk about. And no, here it is. Let me show you. This is the mechanism, okay? Call it overturning of the demographic pyramid, okay? And so, yeah, when the demographic pyramid of plants overturns, of orders, of species, even of individual plants, that's when they die. That's when they become extinct. So plants periodically became extinct when they lose genetic diversity. They've been inbreeding for millions of years, right? They've been sending their pollen or whatever, cones or spores, right? So they've been inbreeding for millions of years. Now the Amish have been doing that for 300 years, and now they're having all kinds of physical and mental problems. Okay, after 300 years, they started out with what, a few hundred, and today they're like 300,000, and yeah, now they're starting to have problems. And this is what happens to the plants, but in a million-year period. What happens towards the end, you know, their population pyramid overturns because, again, they become big. One of the clues. Become big, old, they live to long ages, nothing kills them anymore. They become accustomed to endemic diseases. Okay, they manage to reach a truce with the diseases that used to kill their forefathers. Those that survived had defenses, passed it on to their offspring, and you know, by the time you get to the end, not only these plants are no longer migrating, they become sedentary. They're in a region of the planet. That's when they make their last stand. They're big, typically. They're resistant to diseases because they're, you know, the endemic diseases no longer kill them, maybe makes them sick at most. And they also begin growing vegetatively instead of by seed. Okay? So what happens is the population pyramid of plants overturns. And guess what happens to the animals that depend on that shrinking island? Well, they disappear. And that's the overturning of the ecological pyramid for the animals. Okay? And that's what we're proposing. And I presented this in a paper sponsored, there was a conference sponsored, what was it, 2016 by Oxford University in Prague, Czech Republic. I presented that paper there. I also presented the paper 6 years earlier in 2010 in Aberdeen, Scotland. But nobody reads it. Why? Because I'm not part of the establishment. And certainly I'm not going to talk about climate change, asteroid strikes, or any other extraterrestrial strike. Competition, never even mention it. It has nothing to do with extinction. No, this has to do with internal. It has to do with the vitals. It's an internal thing to every species, and it's going to happen to, you know, all. It has happened and will happen to all species that manage to survive the upcoming extinction very soon, which is the extinction of the mammals. Okay, so that's the theory, and that's what I propose in exchange to what these people propose. Let me show you that they had also a lot of evidence already. I mean, they could figure this out. They never did. I don't know why. Here's the Cretaceous terrestrial revolution. This was what happened during the Cretaceous. And it took them like 4 years to assemble all this information. So this is pretty solid evidence, I think. So for those who Like evidence? Well, here you have evidence. What happened during the Cretaceous? Well, what you see is the angiosperms muscled aside the reigning plants, the conifers. That's essentially what happened. Okay, not only the number of species, but the quantity of individuals, you could say, right? Quantity of plants. Also, it changed the landscape. Was it because of climate change? No, absolutely not. As you can see there to the conifers, they had grown all the way to Cretaceous, and then they followed what I call the curve of life. Okay, here's the curve of life. Okay, this happens to all life essentially. That's the curve of life, and it goes to a peak, and then it comes down. First part, millions of years, when they're battling diseases especially, and predators and so on. Well, you have births that are greater than deaths, or approximately equal. Then you get to the stage where births are greater than deaths. Then, when the pyramid starts overturning, this is the population pyramid, births are less than or equal to deaths, and finally, births are way fewer than deaths. That's the curve of life. And that's what happened here. Okay, this is what you see there. That's the curve of life right there. For you look at the conifers, you can see how they have that little hump there, and that'll give you an idea of what happened in the Cretaceous. While the conifers were slowly dying, slowly I mean in millions of years, right? What was expanding were the angiosperms. What do you think the mammals were eating? Well, what do we eat today? Well, we eat angiosperms. So we radiated with the angiosperms, and the only reason we could not grow too big is the dinosaurs would probably eat us. But once the dinosaurs were out of the way, hey, we could expand with what? With the expansion of the angiosperms, and the conifers just were left behind. And it turns out that they got paid in kind because that's exactly what they did to the ferns. See, at one time it was the ferns that covered the planet. Who displaced them? The conifers. So it's a fight of plants. Okay? The plants kill the other plant, muscle aside the other plant, partly. And the other part is that the other plants essentially suffer an implosion. They have to go through this curve. When they get to the top and they start coming down, all the animals which are on that sliding curve, hey, they go down with them. And that might take 10 million years, sure. Okay. But then, where does that leave the comet? Well, that leaves it in fairy tale land, in Alice in Wonderland. Okay? That's where the asteroid belongs. Okay, here's another sample of what happened in Cretaceous. This is in the seas. Okay, and here you see the forams. The forams at the KT limit. They were the old ones. They followed Cope's law. They became the dinosaurs of their world. They were big. And you can see the forams that replaced them afterwards, they were small. Because what? They start out small, they radiate, and they become big over time. In general terms, that's what the curve of life looks like. Okay, so we have to look at other mechanisms for extinction. And right now we have 200 years in which we have the paleontologists, so-called paleontologists, have no idea whatsoever what causes extinction. Okay? So now you have another theory to ponder. Do you believe it? Not important. Beliefs are not part of science. In science, we explain so that you understand, you reach your own conclusions in your own dark basement. Okay? What's interesting is that in that paper, they say the following. Okay, so the analysis showed that herbivores tended to disappear first among dinosaurs. Yeah, it should be like that. But it says, herbivorous dinosaurs, of all things, could be responsible for this. The group of hadrosaurs, which were also herbivores, were extremely successful as a group and would have displaced the other herbivores. I don't know. I have another paper out there, and it says more or less the following. It says that the Campanian, which was 10 million years or so before the end of the Cretaceous, you had several species of ceratops, like the Triceratops and so on, and several species of hadrosaurs. And by the end of the Cretaceous, there were fewer. Okay? So this is what another paper says. This is the picture. And so you say, well, Bill, who is correct? Who is right here? Well, I can't tell you who is right. I can tell you that these people, the people who wrote those other papers, they went to Hell Creek, Montana, where, apparently the dinosaurs made their last stand, the big guys like T-Rex and Triceratops. And they did a study, and this is the conclusion they reached. And so you have some people who say, these folks of this new paper saying, oh no, the hadrosaurs muscled everybody aside. And the other people say, no, the hadrosaurs also disappeared gradually. Who is right? I don't know. I can't tell you which one is right. I'm just telling you that science is not about numbers. Science is about telling me what the cause of extinction was. And if you're going to put all the all the ideas in one basket just to get your paper approved and say, well, I'm going to pay homage to the asteroid guys. I'm going to pay homage to the climate change guys, also to the competition guys, and all these. You got to be at peace with all of them. What is your paper worth? What is the cause of extinction? Gee, I gave you a cause of extinction. I'm saying it's the overturning of population pyramid of plants, followed by the ecological pyramid, overturning of the ecological pyramid of animals. So you have a direct cause of extinction. The animals essentially, they didn't starve to death like overnight, but they were becoming smaller in numbers, older, having fewer kids, bigger, etc., in a shrinking island. And that's what eventually ended up killing them. At some point, they had to go. There was a crisis, and they went. Asteroid had no role whatsoever in mass extinction.